Hold two magnets together. They push or pull through empty space. No contact, no visible connection. Just force appearing from nowhere. Even Richard Feynman, one of the greatest physicists ever, said he couldn't truly explain why magnets work at a deep level. Magnetism is one of nature's most mysterious forces. Let's explore. Magnetism comes from moving electrons. Every atom has electrons orbiting and spinning. Usually, their magnetic fields cancel out. But in certain materials like iron, electrons align their spins. Billions of tiny magnetic fields combine into one big one. Every magnet is essentially organized electron spin. It's quantum mechanics you can hold in your hand. Every magnet has a north and south pole. Opposites attract, same poles repel. Cut a magnet in half, you don't get separate poles. You get two smaller magnets, each with north and south. Scientists have never found a magnetic monopole, a particle with only one pole. It's one of physics' unsolved mysteries. Earth itself is a giant magnet. Molten iron churning in the outer core creates a magnetic field that extends thousands of miles into space. This magnetosphere shields us from deadly solar radiation. Without it, the solar wind would strip away our atmosphere. Mars lost its magnetic field and became a dead world. Earth's magnet keeps us alive. Here's something wild. Earth's magnetic poles flip. North becomes south, south becomes north. This has happened hundreds of times in Earth's history, roughly every few 100,000 years. We're actually overdue for the next flip. During the transition, which takes centuries, we'd have a weaker, chaotic magnetic field. Compasses would go crazy. Ancient Chinese discovered that lodestone, naturally magnetic rock, always points north. The compass revolutionized navigation. Ships could finally cross oceans without seeing land. European exploration, global trade, the modern world, all made possible by a simple magnetic needle. A tiny rock changed the course of history. Many animals sense Earth's magnetic field. Birds migrate thousands of miles using internal compasses. Sea turtles return to the exact beach where they were born. Salmon navigate ocean and rivers magnetically. Even some bacteria contain tiny magnetic crystals. How do they do it? We're still figuring that out. Nature got there first. In 1820, Hans Christian Ørsted noticed a compass needle move when electric current flowed nearby. Electric current creates magnetic fields, and moving magnets create electricity. This connection, electromagnetism, is one fundamental force. Motors, generators, transformers, all based on this beautiful relationship. Electricity and magnetism are soulmates. Wrap wire around iron and run current through it. Instant magnet. Turn off the current, magnetism disappears. Electromagnets can be controlled and made incredibly powerful. Junkyard cranes lift cars with them. MRI machines use superconducting electromagnets. We've learned to turn magnetism on and off like a light switch. MRI machines use magnets 60,000 times stronger than Earth's field. They align hydrogen atoms in your body, then pulse radio waves to knock them out of alignment. As atoms realign, they emit signals that computers turn into images. Doctors can see inside you without cutting, all thanks to mind-blowingly powerful magnets. Magnetic levitation trains float on magnetic fields. No wheels touching track. Electromagnets lift the train and propel it forward. The Shanghai maglev reaches 270 miles per hour. Japan's prototype hit 374 miles per hour. With no friction from contact, maglev trains are faster, smoother, and quieter. The future floats. Cool certain materials to near absolute zero and something magical happens. Electrical resistance vanishes. Current flows forever without losing energy. Superconducting electromagnets are insanely powerful, used in MRI machines, particle accelerators, and fusion reactors. The Large Hadron Collider has over 1,600 superconducting magnets. Cold plus magnets equals physics breakthrough. Superconductors do something amazing. They expel magnetic fields completely. Put a magnet above a superconductor and it hovers, locked in place. You can push it around and it returns. This is called flux pinning. Scientists are working on floating vehicles, frictionless bearings, and hovering architecture. Science fiction becoming science fact. Lab magnets have reached over 1 million times Earth's magnetic field strength, but nothing compares to neutron stars called magnetars. Their magnetic fields are a quadrillion times stronger than Earth's. A magnetar halfway across the galaxy could erase your credit cards. The universe makes our strongest magnets look like refrigerator magnets. Every file on your computer is stored magnetically. Hard drives have spinning platters coated with magnetic material. A tiny head writes data by magnetizing microscopic regions north or south. Billions of magnetic bits store your photos, videos, and games. Your entire digital life exists as patterns of magnetic orientation. Magnetic bracelets and healing magnets are a multi-billion-dollar industry. Bad news, there's no scientific evidence they work. The magnetic fields from these products are way too weak to affect body tissue. Real medical magnets, like MRI machines, are thousands of times stronger. Save your money. Physics doesn't care about marketing. Your body does have some magnetic properties. Hemoglobin in blood contains iron, though it's not magnetic like a fridge magnet. Your brain generates tiny magnetic fields from neural activity, detected by magnetoencephalography. Some researchers think humans might have vestigial magnetic sense. The jury's still out on that one. Magnets can lose their power. Heat a magnet above its Curie temperature, and the aligned domains become random, destroying magnetism. Strong impacts can knock atoms out of alignment. Opposite magnetic fields can demagnetize. Even time slowly weakens magnets. That childhood magnet on your fridge? It's probably weaker than when you got it. Every magnet has north and south poles. But theoretically, particles with only one pole might exist. Magnetic monopoles would be revolutionary for physics, completing the symmetry between electricity and magnetism. Scientists have searched for decades. Some theories say they formed in the Big Bang. We haven't found one yet. The hunt continues. Magnets will shape tomorrow. Fusion reactors will use superconducting magnets to contain plasma hotter than the sun. Magnetic nanoparticles will deliver medicine directly to tumors. Quantum computers may use magnetic states for processing. Magnetic launches could send rockets to space without fuel. The invisible force has an unlimited future. Magnets are everywhere, in your phone, your car, your doctor's office, your planet. They work through empty space by invisible force. Even the greatest minds can't fully explain why they work at the deepest level. Magnetism remains a beautiful mystery, practical and profound. Thanks for watching, and stay attracted to science.